For my lab report, I wanted to look into the motion of a bouncing ball, so I picked a golf ball and dropped it. It's something that combines the energy principle with Newton's second law and made for a pretty interesting model in Python. When I drop the ball, you can easily see that the height the ball bounces back up to is never as high as the initial height. On the right is the tracker data of height versus time, and although the camera was a little tilted to the right, it was a good recording and I was able to correct the axes in tracker. More on the maximum heights of each bounce. Using the data from the tracker video, I calculated that each bounce came up to 78.9% of the height of the last bounce. This trend continued for each bounce of the golf ball. As far as motion is concerned, the only force acting on the golf ball is the weight force. This means that the net acceleration equals 9.8 meters per second squared downwards. So, when it hits the ground from a drop of height h, it will have a velocity of root 2 gh. Following this train of thought, after the next bounce, it will have dropped from a height of 0.789 times h, and will land with a velocity of root 2 gh times 0.789. It will use this to help create a Python code. Now, why isn't the ball returning to its full height? The energy principle states that change in energy is equal to the work plus heat. Since there is no heat transfer in the system, some work must be done in the bounce. So this must be equal to the change in gravitational potential energies, which is mg delta h, and this factors out to be 0.211 times mg times the initial height. During collisions such as a bouncing ball, there is a relevant property called elasticity, which is the object's ability to return to its original shape. If we call the elasticity of the golf ball c, we get that c squared is the ratio between the heights of each subsequent bounce, which is also equal to 0.789. This helps us find that the elasticity of a golf ball is 0.884, which we will use in the Python model. Here I marked the important parts of the code. The ball is in free fall, so the only force acting on it is the weight force, when you neglect the minuscule drag force. There is nothing different about this lab than the motion of a falling object except for the embedded if statement. This is the way it works. While the ball is above the ground, nothing happens. The ball just keeps falling until it goes below 0. At that point, the statement resets the ball's height to 0 and sends it back up with a velocity of c times the original velocity, where c is the elasticity of the golf ball, which is 0.884. This is what I get when I run the code. The ball starts from a height of around 1.2 meters, just like the tracker video, and the only difference is the time it takes to complete each bounce. In orange is the model, and in blue is the observed data. As you can see, the predicted height of each bounce is very accurate. However, the timing of the bounces are off, and honestly, I have no explanation for this. The only thing I can think of is that in the real system, there is some time that passes during the bounce, unlike my model, which treats the collision as instantaneous. This is the end of my lab report for Lab 5, and I hope you learned something about the physics of a bouncing ball.